Assalamualaikum warahmatullahi wabarakatuh. My name is Aini Stirman. I'm from electrical engineering student at Universitas Al-Azhar Indonesia, and I will I would like to present the results of the internship that I have participate in PLN Icon Plus since 21 ages 20 and 23. So here is the title of my present that I would like to presentation. Design planning for 22 kilowatt peak PV rooftop in the Muhammadiyah Gamping Hospital using helioscope. Here's my contents: abstract, introduction, literature review, result and discussion, conclusion, and references. So here's one, the abstract. Installing of PV rooftop is one way to reduce dependence on fossil energy sources and switch to renewable energy. PV rooftop also has various economic, environmental, and social benefits. This internship report discusses a simulation of installing a PV rooftop at a Muhammadiyah Gamping Hospital in Yogyakarta using helioscope. The installation process begins by knowing the location to be simulated, checking radiation exposure at the location of PV rooftop that we installed, then simulating the implementation of the installation with the appropriate capacity as agreed. Based on the result of this practical work report, it can be concluded that the use of helioscope makes it easier for users to predict and simulate the implementation of PV rooftop at Muhammadiyah Hospital, Yogyakarta of 22 kilowatt peak. So here's the introduction, and let me explain about PLN Icon Plus a little bit. So PLN Icon Plus is a subholding or subsidiary of PLN Persero atau PLN Pusat. And PLN Icon Plus manages PLN Mobile, this PLN Mobile, Smart Home, Iconet, Wi-Fi, kayak Wi-Fi. And then electric charging vehicle or electric vehicle, and this PV rooftop. PV rooftop is a form of renewable energy that utilizes solar energy, which is converted into electrical energy and installed on the roof. Muhammadiyah Gamping Hospital proposed installing PV rooftop on one of their buildings' roofs, and there are three recommended buildings. However, the customer asked for installation in the Erwin building. So Erwin building is this building. In terms of shading and radiation measurements, all buildings are equally good, which means there's no shading, high radiation emissions, and there are no issues with installation in the three buildings. PV rooftop is a form of renewable energy that utilizes solar energy, which is converted into electrical energy and installed on the roof. Muhammadiyah Gamping Hospital proposed installing PV rooftop on one of their buildings' roofs, and there are three recommended buildings. I have the yes. So this building is the name of Erwin Buildings, and it should be there are two buildings in this and in here. Here's one, this building ini nggak kelihatan, is canteen, and in here is dak-dakan. However, the customer asked for installation in the Erwin building. So Erwin building is this building. In terms of shading and radiation measurements, all buildings are equally good, which means there's no shading, high radiation emissions, and there are no issues with installation in the three buildings. And so this you can read by yourself about renewable energy has many advantages like So this is the Indonesian government has issued various policies to encourage the development rooftop, including Presidential Regulation number 22 of 2017 concerning Rencana Umum Energi Nasional about capacity of 6.5 gigawatt di tahun 2025 dan and we can use PV rooftop for 1 gigawatt. So it's the potential from PV rooftop. And regulation of the Minister of Energy and Mineral Resources, number 13 of 2018, concerning the acceleration of the development large-scale solar power plants and rooftop solar power plants of PV rooftop, which regulates the procedures for building and utilizing PV rooftop. SDM-nya. So the Muhammadiyah Kambing Hospital building has quite large electrical power requirements, and the need for electrical power can increase along with the increase in the number of patients and the facilities owned by the hospital. And installation of PV rooftop is one solution to reduce electricity costs and greenhouse gas emissions so that it can help overcome climate change. PV rooftop can produce electricity from solar energy, thereby reducing independence on fossil energy. And Helioscope is a software that can assist in PLTS design planning. And using the Helioscope, you can get an optimal PV rooftop design that can produce maximum capacity. We go with literature review about installation simulation. Why Helioscope? Helioscope is a software used to model PLTS system. The Helioscope is a part of the planning steps for PV rooftop installation. Helioscope has various features that can help in PLTS design planning, such as calculation of optimal solar panel, orientation and tilt, shading calculations, calculation of electricity production, can choose the materials that we're gonna use. And by using this Helioscope, an optimal PV rooftop design can be obtained that can produce
maximum electricity as a basis for calculating the financial model and the power capacity to be installed and material specifications. In this picture, determine the type of PV module used, namely thermal solar with a maximum power rating of 550 using Huawei type inverter. Then determine the PV module used is 40 with a capacity of 22 kilowatt peak. And what is the use of Global Solar Atlas? So Global Solar Atlas is a free online map-based application that provides various information about solar resources and some global, regional, and country geographic information system or GIS data to support increasing solar power in client countries. So the aim of the Global Solar Atlas is to be able to present summary data on the potential of solar power and solar resources globally to anyone who uses it. The higher the radiation produced, the better it is for installing rooftop PV in that location. At this location, the radiation obtained was 4,892 kilowatt hour per square meter. A peak sun hour, or PSH, is a unit used to measure the amount of sunlight available for generating solar energy. It's not about how many hours of sunlight there are in a day, but rather how intense the sunlight is during those hours. So, the peak sun hour obtained 4,892 kilowatt hours per square meter divided by 1 kilowatt per square meter and equals 4,892 hours, because a good irradiation value is above 1,000. So this is the final image of Helioscope design. Then here the specification of the design are explained, such as roof type, namely flash mount raking roof, total roof area 593.5 square meters, slope of the module 15 degrees, And the rooftop PV model uses Trina solar with a rated maximum power, or Pmax, of 550 watts. 50 modules and installed landscape or horizontally, and system capacity of 22 kilowatt peak with estimated annual production of 28.7 megawatt hours. Apart from that, the installation of rooftop PV at Muhammadiyah Hospital Jogja will produce a green impact, such as reduce carbon emissions for 25 years. There were 15,302 trees planted over 25 years, and avoid using a car for 2,712,779 kilometers for 25 years. And after simulating the PV rooftop designs and obtaining and identifying the capacity requirements, amount of material needed, specifications, power required, then it can be entered into Icon's financial model, which is then submitted to the customer. If the customer estimates this capacity, then the amount of investment the customer will get is that. And here's the conclusion. So from the activities that have been carried out, it can be seen that using PV rooftop is the same as joining in to protect the earth, because installing PV rooftop can reduce greenhouse gas emissions, so it can help overcome climate change and help the success of the Paris Agreement. Not only that, installing PV rooftop also helps reduce monthly electricity bills from PLN, and can even produce electricity independently if the installation is done off grid. Installing PV rooftop is one way to reduce dependence on fossil energy sources and switch to renewable energy. Using Helioscope makes it easier for users to predict and simulate the implementation of PV rooftop at Muhammadiyah Gamping Hospital, Yogyakarta of 22 kilowatt peak.
Okay, that's all about my presentation. Those are the activities that I carried out during my internship, and there are several other activities that are useful and increase my skills and knowledge, such as learning Excel for electricity reconciliation, taking part in processing permits and related to PV rooftop, attending several meetings related to these permits, working meetings or raker for the next year in the future, and following training from Huawei regarding PV rooftop and many other things. So thank you. That's all for me. Wassalamualaikum warahmatullahi wabarakatuh.